In this video, we are going to learn SAGA pattern for distributed transactions. The SAGA pattern is provided to manage data consistency across microservices in distributed transaction cases. Basically, SAGA pattern offers to create a set of transactions that update microservices sequentially and publish events to trigger the next transaction for the next microservices. If one of the steps is failed, then SAGA pattern trigger to rollback transactions, which is basically do reverse operations with publishing rollback events to the previous microservices. By this way, it is manage distributed transactions across microservices. As you know that it is used some principles inside of the SAGA pattern like publish subscribe pattern with brokers or API composition patterns. The SAGA pattern is a way to manage long-running transactions that involve multiple microservices. It is based on the idea of the SAGA, which is a series of the local transactions that work together to achieve end-to-end use cases. The SAGA pattern is especially useful in distributed systems where multiple microservices need to coordinate their actions. For distributed transactions, the SAGA pattern can help to ensure that the overall transaction is either completed successfully or is rolled back to its initial state if any individual microservice encounters any error. In order to use SAGA pattern in a distributed transactions, we can use a compensating transaction to undo the changes made by each microservices in the events of an error. By this way, we can ensure that the overall transaction is either completed successfully or rolled back to its initial state. The SAGA pattern provides transaction management with using a sequence of local transactions of microservices. Every microservice has its own database and it can able to manage local transactions in atomic way with strong consistency. So SAGA pattern grouping these local transactions and sequentially invoking one by one. Each local transaction updates the database and publishes an event to trigger the next local transaction. If one of the steps is failed, then SAGA pattern trigger to rollback transactions that are a set of compensating transactions that roll back the changes on previous microservices and restore the data consistency. Here you can see an example how the SAGA pattern could be used in e-commerce application for order fulfillment process to handle the rollback scenario. First of all, the customer places an order on the e-commerce website and provides their payment information. The application order fulfillment microservices begins a local transaction and send a request to the inventory microservices asking it to reserve the item in the customer's order, and the inventory microservice begins a local transaction and reserves the item in the customer's order, and the inventory microservices send a response back to the order fulfillment microservices indicating that the items were reserved successfully. The order fulfillment process microservices receives the response from the inventory microservices and assuming everything went as planned, and it charges the customer payment method and commits its local transaction. However, if any error are encountered along the way, the SAGA pattern provides a way to roll back to changes made by each microservices. For example, if the inventory microservice encountered any problem while reserving the items in the customer order, it could send a failure response back to the order fulfillment microservices. In this case, the order fulfillment microservices would execute a compensating transaction in order to undo the charge operation for customer payment method and cancel the order. That means it is rolling back to entire fulfillment process. As a result, the SAGA pattern is useful tool for managing distributed transactions in microservice architectures. It allows us to ensure that the overall transaction is either completed successfully or is rolled back to the initial state. So this will provide a resilient and reliable distributed systems when it comes to applying to end-to-end use cases. There are two types of SAGA implementation ways. These are the choreography-based SAGA implementation and orchestration-based SAGA implementation. So now let's explain choreography-based SAGA implementation.